In this video, I am going to find the initial basic feasible solution of the given transportation problem using the least cost method. F1, F2, and F3 are the sources, while A, B, C, and D are the destinations. These values are the unit costs. Find the cell with the least cost. If there are two cells with the same cost, allocate to the cell with the lower numbered row. In this case, we have these two 8s, so we allocate to the cell in row F2. Compare the supply and the demand and take the minimum of the two values. The minimum between 40 and 55 is 40, so we allocate 40 units to this cell. Since we have met the supply for row F2, we have to cancel out these cells to indicate we can no longer allocate, and then adjust the demand by subtracting these 40 units from the 55 that we have to remain with 15 units. We move on to the next cell with the least cost, which is this cell, and we compare the supply and the demand. Comparing 60 and 65, the minimum of the two values is 60, so we allocate 60 units to this cell. We have met the supply for row F3, so we cancel out these cells to indicate we can no longer allocate. We adjust the demand by subtracting these 60 units from 65, and we have a 5. We move on to the next cell with the least cost, which is this cell. Comparing the supply and the demand, we are comparing 100 and now 5 units. So the least between the two values would be 5. So we allocate 5 units to this cell. Adjust the supply by subtracting these 5 units from 100 to remain with 95. We move on to the next cell with the least cost, which is this one. Compare the supply and the demand. For the supply, we're comparing 95 to the demand of 30, and the minimum of the two values is 30, so we allocate 30 units. Adjust the supply by subtracting these 30 units from 95, and we remain with 65. We move on to the next cell with the least cost, which is this cell. Compare the supply and the demand. When we compare 65 and 50, the minimum of the two values is 50, so we allocate 50 units to this cell, and we have to adjust the supply by subtracting these 50 units, and we remain with 15. Then we move on to the last cell, which is this one. Comparing the supply and the demand, we are comparing 15 and 15, so we allocate these 15 units to this cell. All cells now have an allocation or have been crossed out, so we move on to interpret this. From F1 to A, we have allocated 30 units at a unit cost of 14, so we multiply 30 and 14 to get a cost of 420. From F1 to B, we have allocated 50 units at a unit cost of 16. We multiply 50 and 16 to get a cost of 800. From F1 to C, we have allocated 5 units at a unit cost of 12. We multiply 5 and 12 to get a cost of 60. From F1 to D, we have allocated 15 units at a unit cost of 20. We multiply 15 and 20 to get 300. From F2 to D, we have allocated 40 units at a unit cost of 8 to get a cost of 320. From F3 to C, we have allocated 60 units at a unit cost of 8 to get a cost of 480. The total of these costs is 2,380. Please note that the initial basic feasible solution might not be the optimal solution. It only serves as a starting point for finding the optimal solution using methods like the modified distribution, MODI, or the stepping stone method. Thank you for watching.